Now let's go to example 3. This time around, we want to find the derivative of sine inverse of y. So this time we're dealing with sine inverse of y and sine inverse of x. So you can see both of them, they are sine. So, but the only thing is that the first one is sine inverse of y. So we are going to differentiate it with respect to y. The second one is sine inverse of x. We are going to differentiate it with respect to x. But the point is this. Do we remember about the graphical illustration of sine x? Remember that sine 0 is 0. So which means that the graph of sine x will always pass through the origin. Why? Sine 0 is 0. So if sine 0 is 0, then definitely the graph of sine x must pass through the origin. So recall that sine inverse of y is the what? Is the inverse of sine x. So the next thing is this, we are going to make x the subject of formula so that sine inverse of y can give us our x. So we are going to differentiate both sides now with respect to x. What does that mean? It means that we are going to say d dx of sine inverse of y, d dx of x. So that's what we are going to do now. But remember, d dy of sine inverse of y, it requires us to use chain rule. You know, like I've said, d dx of sine inverse of y, it requires us to use chain rule. So what we are going to do is this. Instead of writing d dx, we are going to replace it with d dy multiplied by dy dx. You know, if y is sine x, what is the y dx? Cos x. Exactly. So if our y is sine x, the y dx is what? Is cos x. So instead of writing the y dx in the expression, we are going to replace it with what? With cos x, because the y dx is what? Is cos x. Of course, we can now divide both sides by cos x now. So when we divide both sides by cos x, we have that. Then the next thing is for us to now use the fact that that sine square x plus cos square x is equals to 1. Trigonometry. Of course, we can make cos square x to be the subject. Remember that what we're having is 1 over cos x. What we're having is 1 over cos x. So if we have 1 over cos x there, so this time around from the trigonometry identity, we need to make our cos square x the subject. So that will give us cos square x equals what? 1 minus sine square x. We just need to substitute y equals to sine x back to our expression. And that will give us what? It will give us cos x is equals to square root of 1 minus y squared. You know, what we're having before is cos square x, isn't it? So we can find the square root of both sides. So as usual, we can now substitute everything back to 1 over cos x to give us 1 divided by square root of 1 minus y squared. So finally, we've arrived at our destination. So based on this now, we can now see now that if we are to differentiate sine inverse of y with respect to y, what we get is 1 divided by square root of 1 minus y squared. Also, if we are to differentiate sine inverse of x with respect to x, what we are going to get is 1 divided by square root of 1 minus x squared. Thank you very much. See you. Okay, so let's proceed to the example 4. This time around, we want to find the derivative of cos inverse of y and cos inverse of x. Aha. So the first one, cos inverse of x, of y, we're going to differentiate it with respect to y. And cos inverse of x, we're going to differentiate it with respect to x. But before we proceed, let's talk about the graphical illustration of cos x. One important thing about this is the fact that at a 0, cos is 0 is what? Is 1. Aha. So that is the difference between the graphical illustration of cos x and sine x. That of sine x at is 0, sine 0 is 0. So it must pass through the origin. But when it comes to cos 0 is what? Is 1. It must never pass through the origin. It can only pass through 1. Y equals to 1. So that is it. Another thing about sine and cos is that both of them, they are continuous functions. So if you go back to our first class, which is a function of real variables, how you see it in our lecture note, we talked about it very well. So as usual, we are going to follow the same procedure. The first thing, we recall that cos inverse of y is the inverse of cos x. So meanwhile, y is equals to f of x is equals to what? Is equals to cos x. So we're going to make x the subject of formula, so that what we're going to have will be cos inverse of y is equals to x. So what is the next thing now? We're going to differentiate both sides with respect to x, which means that we are to obtain d dx of cos inverse of y and d dx of x. Of course, we are going to use chain rule again, because d dx, we are going to break it down to 2, which will give us d dx is equals to d dy dx. Meanwhile, if y is equals to cos x, what is the y dx? If y is equals to cos x, what is the y dx? That is minus sine x. So we replace the y dx with minus sine x. That's why we put it inside the bracket. You know, it's multiplying d dy cos inverse of y. So we are going to use the identity, that trigonometric identity, which says that sine square x plus cos square x is equals to 1. So from this, we can actually make sine square x the second formula, which will give us sine square x is equals to what? 1 minus cos square x. But if you go back to the question, we can actually pick that if y is equals to sine x, let's substitute it into the expression. And that will give us sine square x is equals to 1 minus y squared. And with that, we can actually have our sine x to be square root of 1 minus y squared. So that takes us to our final destination, which is very simple. As you can see now, we can now conclude that d dy is equals to cos inverse of y is equals to minus 1 divided by square root of 1 minus y squared. So if you look at this very well now, we can now see clearly now that d dy of cos inverse of y is equals to minus 1 over square root of 1 minus y squared. In fact, welcome to the last example. This time around, we are going to consider y raised to power 1 over 3. Y raised to power 1 over 3 is also an inverse function. Remember, I mentioned something like that during the physical lecture on the functions of real variables. So this time around now, we are having y raised to power 1 over 3. We want to differentiate it with respect to y. And at the same time, x raised to power 1 over 3. We want to differentiate it with respect to x. So what are we going to get? Both of them, they are inverse functions. But before we proceed, let's remember that we are having, we can see the graphical illustration of x raised to power 3. Remember, the graph of x raised to power 3, I mentioned it during the classroom that there is a possibility, it's not even a kind of possibility, it's a must that if you set x raised to power 3 equals to 0, then it's very obvious that there are 3 roots. Yes, there are 3 roots. There are 3 roots, and those 3 roots, they're actually on x equals to 0. So we can put it this way that 1 over 3 is the inverse of x raised to power 3. That is why I show you the graph of x raised to power 3. So in this case, we can now say that y is equals to x raised to power 3. So as usual, we are going to make x the subject of the formula. We just need to follow the same procedure as well. You know, the same procedure in the sense that we, after making x the subject of formula, we differentiate both sides with respect to x, isn't it? So, and the side with d dx of y raised to 1 over 3, we use chain rule again. That will give us d dy multiplied by dy dx. And if you differentiate x, you have what? You have 1. So you proceed again to the fact that if our y is equals to x raised to power 3, what will be our dy dx? And that will give us 3x squared. So as usual, we replace the y dx with 3x squared. Then we divide both sides by 3x squared. That will give us 1 over 3x squared. Then we substitute y equals to x raised to power 3. Okay? And when we do that, we realize that what we have on our right-hand side, on our left-hand side, which is d dy of y raised to power 1 over 3, is give us this. So if we replace y with x, you now see that it's possible for us to find the derivative of inverse function using this procedure. In fact, as you can see here, we've been able to use this idea to differentiate trigonometry. And remember that we start with exponential, and this one is polynomial, which is x to the power 1 over 3, x to the power 3. So the approach is very important. It's just the same procedure. So we can now proceed to our online revision class now. Thank you very much for watching these videos. Thank you very much. See you again. Bye.